Seriously.
Storybook. Honestly.
Day 15. Here we go. Hopefully I can do this. No. Day 15. Here we go. Okay, so we're doing diameter. Dime has a radius, so here's my circle. And again, I like. Here's the radius, 0.85 centimeters, which measures closest circumference. So circumference equals pi times d, right? And pi, we're going to leave it. The diameter, if the circumference here, if the radius is 0.85, obviously, the diameter is going to be 1.7. So it's not in terms of pi, so you actually have to multiply this 1.7 times pi, and you get 5.34, which is closest to this one. Not that bad. Number 4, in the figure below, each side of the square measures 8 centimeters. So I know this is 8, this is 8, this is 8, this is 8. What's the approximate circumference of the circle? Well, you're going to say, I don't have any information of the circle, but you do. So if this is a dot, think about it. If from here to here is 8, what would be half, which would be the radius? The radius is 4. So C again equals pi d. If the radius is 4, you know that the whole thing is obviously 8, right? So pi times 8, and we want to multiply pi times 8, and you get 25.13 rounded, or 25.12. Number 2, what is the circumference in centimeters of the largest circle that can be drawn on a piece of paper? 16. So if you have a piece of paper, and it's obviously a square piece of paper, and this is 16, this is 16, this is 16, this is 16, and you draw a circle, right? What's the largest circumference? Well, here's the circle in the side, and the circumference is obviously 16, so this would be C equals pi d. C equals pi times 16, because that would be the diameter of that circle, and then 16 times pi, enter, equals 50.26. So the biggest circumference would be 50.26 centimeters. The circumference of the top of a soda can is 7.85 inches. So the top of the soda can, the circumference is 7.85. What is the radius? So what's the radius of the top of the soda can? Again, so we have circumference, so you have to use this one. The circumference is 7.85. I'll write 7.85 pi d divided by pi. And 7.85 divided by pi, enter, equals, my diameter according to this is 2.5 rounded. So the diameter is 2.5, which means the radius is half of that, or 1.25. Okay. Number 3, the diameter of a circular basketball rim is 18 something inches. Hang on a second. The diameter of a circular, and again, I like that you draw. The diameter is 18. What's the approximate circumference? So the circumference, the distance around the basketball rim. So we're looking for that value. C equals pi d. So pi times 18. Oh, this one's super easy. 18 times pi, which is going to give us 56 point something, 55 rounded. 56.55, or in this case, this one. 6, the circumference of the circular table on the porch. So let me draw a circumference here. It says that it's 72 pi. What is the radius of this circle? C equals pi d. Circumference is 72 pi equals pi d. Divide both sides by pi. And the diameter becomes 72. But I'm not interested in diameter, I'm interested in the radius, which is half, so it's 36. Use the diagram below to answer the following. So someone install this light, and the light shines on the yard, right? So the area that the light is shining on is this part. All this is being shined. with a radius of 20 feet. So I know that this from here to here is 20 feet. What's the area of the yard that's lit by the new light? So we want to find the area of a semicircle, right? This area is where the light's shining. So A equals pi r squared. A equals pi times r. The radius here says that's 20 to the second power. So 20 to the second power is 400 times pi. It's going to give us 400 pi, or 1,256.64 feet squared. One.
Do you have a reference?
Wait. Hang on a second. Stop. Pause. So that's that. This one. 3 friends order the pizza shown. The pizza, the area of the whole pizza is 254.34 square inches. Which area is covered by mushrooms? Oh, what? This can't be that easy. Pizza has a total area, so total area is 254.34 square inches, and it's divided into equal portions, equal sections. What is the area of the portion covered with mushrooms? Well, if the total area here is 254.34, and we want the area with the mushrooms, this area, well, just divide it by 3. No, it can't be that. Why would I? Kind of 254.34 divided by 3. Yeah, 84. That's a silly question. Shoot. Stupid question, if you ask me. 9. The largest possible circle to be cut from the 10-foot square board. So I know that 10 feet, this is also 10 feet, right? This distance from here all the way here is 10 feet and so on, because it's a square. What will be the approximate area of the circle? Well, let's draw a diameter here in the circle. Isn't that diameter the same thing as this length here at the bottom? So I know that the diameter is 10. If the diameter is 10, I know the radius is 5, because that's 5, and this is 5. If I know the radius, I can easily find the area, right? So the area is, what will be the area of the shaded region? Okay, so the area, let's find the area of the circle first. The area of the circle is pi times 5 squared, which is 25 pi, but numerically, 25 times pi is going to give me 78.54 rounded. What is this? Feet squared. So this is my circle. And let's find the area of the square. So the area of the square, well, the area of the square is just 10 times 10, right? The area of the square is 10 feet squared. So imagine you had a square shaded, right? You had a square like this, and you made a hole through the middle, right? How much of that square do you still have left over? Well, you got to subtract these two. 100 minus 78.54. It's about, you're going to have about 22, 21 point something left over. 21.46 left over feet square. So the closest one is this. 10. To solve the problem, why do you need to know the circumference? Blah, 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 blah. You need that 1 mile is 5,280 feet. So here is a bicycle wheel. It has a diameter of 2 feet, 6 inches. So I'm just going to write everything into inches. So 2 feet, 1 foot is 12 inches, right? So about 2 feet is 24 inches. So the diameter of this circle is 24 inches, which is 2 feet, plus 4 inches. So this is in inches. 28 inches is the diameter of my bicycle here. And how far will it travel? 35 minutes. So it makes 36 revolutions in 1 minute. So let's find the circumference. So let's find out how much, the distance it covers in 1 rotation. So circumference equals pi d. Pi times 28, and 28 times pi is 87.96, 87.96, and this is inches. So in 1 rotation, so this bike travels 87.96 in one revolution. So, but it does 360 revolutions in 1 minute. So let me multiply this by 60. And in 1 minute, it goes 5,277 inches in 1 minute. Now, it says how far will it travel in 5 minutes? Well, multiply that by 5. 5,277 times 5. We're going to get 26,389 inches. But we want it into miles. Now, remember, 1 mile is 5,280, so we can divide that by 5,280. So we get 4.99, almost 5 miles if we were to what do you call simplify. It's almost 5 miles. A mile a minute. How many square feet of grass will the worker mow round to near the answer near? So here's a field. It's 300, which means this side, this whole thing is 300, which means this side, the whole thing is 280. Right, so let's find the area of this diamond. The area of the diamond is 280 times 300. 280 times 300. And then get that the area of this, the whole thing here, everything is... Okay. The area is 8,400 feet squared, right? The area of the whole mound here, this whole area here. It's 84,000. Did I multiply this right? 300 times 280. 300 times 280. Yeah, 84,000 feet squared. So that's the area of this. Now, obviously they're going to plant grass on this shaded area, but they're not going to plant grass on this little part. If you look at this one, it looks like this. It's 1/4 of a circle, right? So we got to take that part out. So they're not really going to put grass seeds on the whole thing. All that minus, and let's take this. It's not a semicircle. It's 1/4 of a circle. Let's take that part out. So in this, so imagine that circle, and in that circle, the radius, right? This is the radius. So if you imagine, let me continue that circle. This is center, and this will be the radius. So the radius of this circle is 140. Let's find the area. A equals pi r squared. A equals pi times 140 to the second power. 140 times 140, enter, equals 19,600. And I'm going to multiply that by pi. And the numerical answer to that is 61575.21 feet squared. So this area of the circle is 61,575, right? The area of a circle, but we're not interested in a circle. We're interested in 1/4 of the circle, so I have to divide that by 4. So if I divide that by 4, I'm going to get that this area of this, just of 1/4 of the circle, is 15,393.8. So now I can subtract. And minus 15,393.8, and we can find our answer. So 84,000 minus 15,393.8, enter. So the area left over for them to work, to put seed, is this feet squared. Okay, so it's the area of the whole, this quadrilateral minus 1/4 of a circle. Use a diagram below to answer the following question: which is the best estimate for the area of the walkway around the circuit? So I want the area of this, right? So what you have to do is think about, let's find the area of the whole circle. So if this was a whole circle, well, if the diameter of this, the inner circle, is 6, I know that this is 3, right? Because this other side must be 3. So the radius from here all the way, including the walkway, is 5. So that would be the area of the whole circle. So A equals pi r squared. A equals pi times 5 to the second power. A equals 25 times pi will give me 78.54 feet squared. What's up, Dave? Feet squared. Now, I have this huge circle, big circle, which includes everything, right? But I'm not interested in the area of the whole circle, which is what I just found. I'm interested in the circle of, I'm interested in the whole thing minus this part in the middle. I want to take that part in the middle out. So let's find the area of the small circle. The area of the small circle is, again, equals A equals pi r squared. And the small circle, the diameter is 6, which means that the radius of the small circle, this circle right here, it's 3, right? So again, A equals pi times 3 squared, which is 9, and area equals 9 times pi, which is, I have no idea, 28.27. So if I subtract those two, 78.54 minus 28.27, I should get around 50.26, so around there. To 13, again, time. I have, let me do this. The area of a circular garden, the area is a process. So I have a garden, and the whole thing, the area is 804 feet squared. So A equals pi r squared, and then we're looking for the radius, right? So I substitute area, I write 804. I write pi, and radius is what I'm trying to find. Divide by pi on both sides. So 804 divided by pi equals 255. These two cross out. Find the square root of 255. Clear. Square root of 255. 804 divided by pi is 255.92. So find the square root. 255.92, and it looks like the radius is about 16 feet rounded. Let me do 15. A skateboard park has been constructed in the shape of a circle. Skateboard park. The circumference is 188.4. What is the area of the park? Also, I'm trying to find the area, which is... Now, if I know circumference, I can use C equals pi d, right? C equals 188.4 equals pi times d. Divide both sides by pi. I got 188.4 divided by pi, and that's going to give me 59.96 or 59.99. So my diameter is 59.97, I'm sorry. But I'm not in, well, diameter, if I have the diameter, 59.97, I can divide that by 2, and I get the radius. So my radius rounded is 29.99. If I now have the radius of 29.99, I can find the area. A equals pi r squared. So the area equals pi, and the radius we just found is 29.99 squared. So 29.99 times 29.99 equals, and then multiply that by pi, and I'm going to get that the area equals 2,825.55. What is this? What is the units here? Meters squared. So I needed to use the circumference first, find the diameter, and then going back to find the area. One more question, and I don't think I'm going to be able to do it. So I'll do it in like about 10 minutes. Pause. Okay, I think I have one more question. Yeah, I do. So again, so imagine a piece, a cookie, or a, what do you call that? A Pop-Tart. You had a Pop-Tart and somebody comes and takes one bite from this side and one bite from that side. So how much of the Pop-Tart would you have left over? So let's think about the Pop-Tart in its entirety without anyone taking a bite out of it first. And they tell us that this is 1.75 and this up and down is 3.5 centimeters. Well, let's find the area. It's a rectangle, right? So it's just simply 3.5 times 1.75. So our area is of the part 3.5 times 1.75, and that's going to give us 6.100, and we want to round to the nearest square centimeter. So we're going to round to the nearest hundredths, 6.13 centimeters squared. So that's our area of the entire rectangle. Now, you're going to take a bite on this side, and you're going to take a bite on that side. So, but if you notice, if those two bites make up one circle, right? So it's, in essence, you're talking about the rectangle, and somebody, right, removes this part away, which is the same thing as a bite on each side, right? Those two bites combined. So let's find the area of the circle. So the area of the circle is pi r squared. So again, think about this. We want to use the radius. So they gave us a diameter, and they told us that 1.5. So what's half of 1.5? It's 0.75, right? So that's my radius from here to here, radius. So A equals pi times 0.75 squared. 0.75 times 0.75, and then we're gonna multiply that by pi, and we're gonna get 1.77 rounded. So the area of that, this one and this one, right? The area of the circle, and it's one full circle, not half of a circle. So the whole area of these two combined is
Please pardon the interruption. All powers report to
1.77. So let's subtract.
At 2:40 p.m. All powers report to the back of room 121 at 2:40 p.m.
So we're gonna have 6.13 minus 1.77, and we get to the leftover area is 4.36 centimeters squared. So that should have been your answer if that was a multiple choice. Was it? Yeah, 4.36, or rounded to the nearest tens, 4.4. Final answer is B.